Hey guys, so a couple of you have been asking me kind of like the same questions, so I thought I'd make a video and show you some of the shortcuts that I came up with. Hopefully it'll help you with the optics quiz that we have coming up. So basically, whenever he shows you a diagram and asks like a million questions about object space, image space, virtual, real, all that stuff, I'm going to show you step by step kind of how to think about it in shortcuts that will break it down so that you can always fly through these like really quickly, okay? So this diagram is straight from practice exam 2 that was just sent to us today. So as you can see, there are four lenses in series, 1, 2, 3, and 4. Okay, so if you ever notice looking at these questions, every single one of these questions will always ask you specifically about one lens at a time. While it's true that sometimes you can have an image formed by one lens become the object for the next lens, you're still always looking at one lens at a time. So step one is to always isolate whatever lens you're looking at. So, and it's going to be very obvious. When you read the question, it's going to be like blah, blah, blah for lens 1, blah, blah, blah for lens 3. So if it says that, then that's the only thing you're looking at. Everything else goes away. That's the only thing that matters. Everything is relative to that one lens that they're asking you about. So that's step one, okay? Step two is that for the lens that you're isolating, you have to determine what's the object and what's the image, and also where are the objects, or where is the object and where is the image, okay? So the way to think about this is that the light rays that are going towards your lens are going to be your object rays. Those are the rays that are going to be given off by your object, or it's going to seem like that's where the rays are coming from for your object, okay? And the rays that are leaving the lens, those are going to be your image rays, okay? So where your object rays come together, or where your object rays come from, that's going to be where your object is. And where your image rays come together, or where your image rays seem to come from, that's going to be where your image is, okay?
Okay.
So, so step one, isolate the lens. Step two, figure out which ones are your object rays and which ones are your image rays. So let's go through all four lenses and do them one by one. So for lens 1, where are the object rays? What color are the object rays?
Red.
Red, correct. Because the red rays are the rays that are coming towards lens 1. So lens 1, these red rays are the object rays. Where is the object for lens 1?
The object is in between 2 and 1.
B, C, and yeah. So A, B, and C. So where is the object for lens 1?
B.
Okay, so where do let's go back a step. Where are the rays that are going towards lens 1? What color are they?
Red.
They're the red rays, right? Where do the red rays come together?
At B.
I'm sorry for the really shitty drawing. The red rays are coming together at A, okay? So you see how like A is coming towards the lens, and then like you're kind of extrapolating past the lens, but this is where they seem to be coming from. Does that make sense?
Okay.
You see how those rays, like in a straight line, they keep going in a straight line, and they meet at A?
Okay.
So A is going to be your object, because your object rays come together at point A, and that's why A is your object for lens 1. Does that make sense?
Got it.
Okay. So what color are the image rays for lens 1?
Green.
Green, right? Because once these red rays hit lens 1, they don't go to point A, they go to point B, right? They go to point B. Does that make sense?
Yeah.
So that means that the green rays that are leaving lens 1 are the image rays, because image rays are the rays that are leaving the lens, and they meet at point B. So point B is where your image is formed for lens 1, okay? So what about for lens 2?
What is A?
What do you mean what is A?
What is that point?
Oh, A is where your object is for 1, right? But let's work on it backwards, okay? So like point A is the point where these pink rays are coming together, right?
Okay.
And these pink rays are coming together, and they're hitting lens 1. So if the rays that are coming together are hitting lens 1, that means they're going to be the object rays for lens 1. And if they're the object rays for lens 1, then that means that point A is going to be the object for lens 1. Okay?
Okay. So what would 1 be? What type of lens?
Okay, so we're going to get to that later, actually.
Okay.
Well, we'll do that last. But let's just go through and make sure that we can understand step 2. Step 1 is isolating the lens and only looking at the lens. Step 2 is looking at where the object and object rays are and image rays are, okay? So for lens 2, what are the rays going towards lens 2? What color are they?
The blue ones.
Correct, the blue ones. These blue ones over here specifically, right? And then this is kind of tricky. I didn't color code it, so that's why it's weird. But these rays that are leaving lens 2 are also blue. So these are the image rays for lens 2, and these are the object rays for lens 2.
Once they pass the lens, they become an image.
Once they leave the lens, the rays exiting the lens are going to be the image rays. The rays entering the lens are going to be the object rays. So these object rays, these blue rays that are going towards the lens, where do they come from?
They're coming from the image formed from the green image.
Exactly, the green image. So, or the image formed from 1 is going to be the object for 2. But like I said, we're just isolating the system. We're just isolating this lens in right now. We're only going to look at lens 2.
It became diverging from converging.
They became... Yes, that's true. They're converging and now they're diverging. But at this point, point B is where these rays come from, right? So point B is going to be your object point, okay?
Okay.
Does that make sense so far? And then let's look at lens 3. What color are the rays going towards lens 3?
Orange? Well, which one? From the object
Lens
from B?
What rays are entering lens 3, going towards lens 3?
There's 2 different colors going into lens 3.
There's only one color going into lens 3. It's going to be the blue ones. This is tricky, and there's going to be a lot of those things. These rays aren't going to lens 3. These rays are coming out from lens 3. The
Okay.
reason why it's dotted is because I'm extrapolating back to see where these rays are coming
So
from.
it's a virtual image.
Yes. So these rays, which are leaving lens 3, are the image rays for lens 3.
Okay.
Because the rays that are leaving the system are going to be the image rays. And if you trace these rays back to the point where they meet,
Yeah.
then that's going to be where the image is. And because you're tracing it back, that's what makes it a virtual image, okay? And then after it hits lens 4, it becomes parallel, okay? So we've talked about looking at one lens at a time, and then step 2 is determining the object rays and the image rays. The object rays are going to be the rays that are going towards the lens, and the image rays are going to be the rays that are leaving the lens, okay? So now we're going to talk about how to figure out object space versus image space, okay? So let's look at lens 1. Object space is basically anywhere you have either the point where the object is or the rays where the object exists, okay? So, and it's going to be either or. It's going to be, you're only going to look at 2 things, the left side of the lens and the right side of the lens. Those are the only 2 possibilities for object space, okay? So let's look at the left side of this, of lens 1. On the left side of the lens 1, do you see any object rays?
I see rays converging.
Rays going towards lens 1, right? So
Yeah.
if these rays are going towards lens 1 and they're entering lens 1, then they're object rays. So that means there are object rays on the left side of lens, so the object space exists on the left side. And we talked about earlier that the object for A is, or the object for lens 1 is A, which is on the right side of the lens. So that means that the object space exists on both the left side of this of 1 and also the right side of 1.
How could that be possible?
Well, because on the left side of 1, you have the object rays, and on the right side of 1, you have the actual object. So if the left side of the lens or the right side of the lens contains either the object or the object rays, then it's going to be part of the object space. If it contains either the image or the image rays, then it's going to be a part of the image space. So let's look at one again. The image for one is B. We talked about that earlier because that's where these rays that are leaving one, which are the image rays, are going to come to a point at point B. These image rays leaving one are at points. These image rays leaving point one are going to be the image rays for lens one, which are on the right side of the screen, or right side of lens one, and then the object point or the image point of B is also on the right side of lens one, which means that for lens one, the image space is only on the left side, on the right side of the lens. Let's look at a different one. Okay, let's look at 3. So the rays coming towards 3 are these blue rays. So those are going to be the object rays because the object rays goes towards the lens. So that's clearly on the left side of lens 3. So we know now for sure that the object space is going to be part of the left side of lens 3. And then the object itself, where those blue rays seem to be coming from, is at point B, which also is on the left side of lens 3. So that means that the object space exists only on the left side of lens 3 and not on the right side of lens 3 because there's no object rays on the right side and there's no object. The object is not on the right side either. Okay? So that's kind of how you think about object space versus image space. And then next, I'm going to teach you this shortcut about whether something is real or virtual. It's very handy because like in every single question that he asks you, sometimes he doesn't even tell you whether it's converging or diverging. He just tells you whether it's real or virtual. And if you are a visual learner like me and you like to draw pictures, then like it's gonna be difficult to know where to put it. So the shortcut is that objects that are on the left of the lens are always going to be real objects. Objects on the right of the lens that you're looking at are always going to be virtual objects. And then for the image, it's the opposite. Image points that are on the left of the lens are always going to be, image points that are on the left of the lens are always going to be virtual, and image points on the right of the lens are always going to be real.
All right, so repeat that one more time about the objects.
I'm going to repeat it one more time because hopefully I said it right. Objects that are on the left of the lens are always going to be real, and then objects that are on the right of the lens are always going to be virtual. Images that are on the right of the lens are always going to be real, and then images that are on the left of the lens are always going to be virtual. So it's basically the opposite.
Okay.
So if you look at lens 1, where's the image point for lens 1 again?
Image is at A.
Correct, A. And is A on the left or right of 1?
On the right side.
So is it real or virtual?
It's virtual, definitely.
Correct, because it's on the right side of 1, right?
But that's a tricky one, right? Isn't it? Because wouldn't converging rays, wouldn't the lens power?
You can, if you want to, you can remember it converging, diverging. That's the way he taught it in class. If that's working for you, then don't even use this shortcut. But if that's been confusing for you, then this is just another way to think about it. Okay? So an object on the right of the lens is always going to be virtual. An object on the left of the lens is always going to be real. And the opposite is true for images. So let's look at B, which is the image for 1. Is the image on the left or the right of 1?
The image?
Image point B, is B on the left side or the right side of lens 1?
It's on the right side.
It's on the right side. And images on the right side of the lens are always real. So that means that B is a real image for 1. Does that make sense?
Real image, got it.
Okay.
It's a virtual object with a real image.
We're looking at one lens at a time, right? Okay. So exactly. So for lens 1, you have a virtual object of A, and you have a real image of B. Okay? Does that make sense? So let's look at 3. Where's the object point for 3?
C.
Okay, so the rays that are going towards lens
Actually,
3,
wouldn't it be B?
It is B, correct.
Okay.
Because the rays that are going towards B are going to be the object rays. And the object is where the object rays come from. And the object rays the blue rays are coming from B, right? Now, is B on the left side or the right side of lens 3?
Left.
So is it a real or a virtual object?
It's a real object.
It is a real object, that is correct. Now let's look at the light that's leaving lens 3. So now these pink rays, these orange rays are leaving lens 3, which makes them the image rays. Where do the image rays, where are they coming from? What point?
Those image rays, where are
Yeah.
they coming from? Are you talking about the focal point?
You can answer as well if you want to.
C.
Point C, correct. So they're coming from point C. So that means that C is the image for point 3. Is C on the left or the right side of the lens?
Left.
On the left. So is it a real or virtual image?
It's virtual.
It's virtual because, by the definition or the shortcut that I just gave you, if an image is on the left side, it's going to be virtual. And if an image is on the right side, it's going to be real, okay? Let's look at lens 4, because up until like a day ago when he mentioned it in passing, I would have gotten this wrong. So where is the image formed for lens 4?
Where does the image form?
What color are the rays that are leaving lens 4, the last lens of the system?
Is that violet?
Yes, these violet rays are the rays that are leaving lens 4. And these rays are parallel, so where is the image formed for this lens?
Infinity?
Infinity, exactly. So it's infinity that way. Is it real or virtual?
It's real.
It's real, yeah, because parallel light always also forms a real image that's infinity far away. So that's the one caveat. It's a little bit trickier using my method for something like this because you don't have an image that actually forms because these rays are parallel. You can't trace them back anywhere. So that's the one thing that you need to remember is that if you have parallel rays coming off from a lens, then it's going to form a real image. Okay. Let's see. And then let's go through this and just kind of go through every lens and determine whether they're converging or diverging, okay? So a converging lens is going to make the slope of the incoming rays even more steeper. They're going to come to a sharper point. And a diverging ray is going to make the rays that are, or a diverging lens is going to make the rays that are leaving the lens a little bit less steep and a little bit wider out, okay? So looking at lens 1, you can see that these rays are coming in, they're converging, but even though they're still converging after they leave lens 1, they're a little bit less steep. So they're super steep before, they would have formed there, but as you can tell, they kind of shift out a little bit. So that means that that lens 1 is making them less diverging, which means that lens 1 is less converging, which means that it's going to be a diverging lens. So even though the rays coming in are converging and the rays leaving are converging, lens 1 is still a diverging lens because it's making it less steep. Does that make sense?
Okay, and that's how that forms that virtual image on the ray. Virtual object, actually. Right?
Yeah, virtual objects aren't formed, they're just there. So, this virtual object was formed by another lens that is not on this board right now.
It's a mirror?
So, not a mirror. So, looking at lens 2, point B is going to be the object for lens 2. So this is, I feel like this is why they put it here. Like, what happens to the slope of these rays once they exit lens 2?
Nothing.
Nothing happens to them, right? So that means this is a plano lens. Like, nothing's going on here. As our professor loves to tell us, the power's in the curves. So maybe this is just like a flat slab with no curves, and that's why there's no power in this lens. Okay? So lens 3, what happens to the rays after they hit lens 3? Do they become further apart, or do they become closer together?
Further apart.
Further apart. So is this a diverging or converging lens?
Diverging.
Diverging, right. So what about lens 4? What happens to these rays after they leave lens 4? Do they go more diverging, or do they become less diverging?
Less diverging.
Less diverging. So is this a diverging lens or a converging lens?
Converging.
Very good. So that's a converging lens. Okay. And then I guess the last shortcut that I have to show you guys is something that I kind of already mentioned in class and verified with him. But it's basically if you have the object and the image for a lens on the same side, then the magnification is always going to be upright. And then if they're on opposite sides, it's always going to be inverted. So if you look at lens 1, the object for lens 1 is point A, and the image for lens 1 is point B. because they're both on the right side of lens 1, the image that's formed is going to be erect. Okay?
Wow, that just made everything so much easier.
So that's just one shortcut. This always works. And then for lens 2, the object is over here, point B, and then the image, there is no image formed. The image is also over here, I guess, so it's also erect because nothing happens to it. And then for lens 3, the object is over here, point B, and the image is over here, point C. So is the image for lens 3 going to be erect or inverted?
Inverted.
It's going to be, is the object on the left or the right side of lens 3?
On the left.
Is the image on the left or the right side of lens 3?
On the left.
So is it going to be erect? It's going to be erect because it's on the same side, right? So if it's on the same side, it's always erect. If it's on the opposite side, it's going to be inverted. So that's kind of like that's all the shortcuts I have for you guys for now. I mean, there are different ways in which I kind of came to the logical conclusion of those shortcuts, and I could like derive the SRS formula for you as well, but I'm not going to waste your time with that. You can ask me if you want. But yeah, hopefully this helps you kind of grasp the exam a little bit better. I know that time is going to be a huge issue on this, so hopefully when we get like 10 of these questions, it'll just be like yes, and just fly through them really quickly and answer them all correctly. So good luck on the test tomorrow, guys, and you can ask me if you have any more questions.